Hey guys, this is Calc 1, section 2.2 or chapter 2.2, definition of limits. So basically, this section tells us what limits are, and the definition is in your textbook and all that. But to see it, how it's applied, well, that's the most important thing. So there's going to be some graphs here I'm going to draw by hand. Oops, well, actually, that should be all right. I'll do the best that I can. So suppose I have this graph. With, 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5, make that a little bigger, 6. And suppose I have, a point here, and I have an open circle at the point 2, 3, and I have another open circle at the point 3, 4. And then 2, 5. I have that. And the graph, say, looks like this. It's not the best drawing. I'm clearly not an artist. Actually, let me just erase that. Make the line a little better. So suppose we have this function. It's y equals f of x. It's some arbitrary function. And suppose I want to find certain values and limits. So for instance, say I want to find f of 1. Well, f of 1, well, if I look here, this is 1. Where does it hit? Bam, right at 2. Right? But now let's say I want to take the limit as x approaches 1 for f of x. Well, this is 1. Where does it hit? At 2. So in this case, the limit and the value of f1, in this case, the limit x equals 1, excuse me, in this case, the limit as x approaches 1 and f of 1, they happen to be the same. Well, now let's say I want to find f of 2. Well, where's 2? Right here. And right here, it's defined. It's a point. So f of 2 is 5. But now let's look at the limit as x approaches 2 for f of x. Well, it hits here at 3. It's an open circle. So that's the actual limit, because with a limit, we can go a little above 2 to find it, or a little below 2, which is one-sided limits. And if those both approach the same value, then the limit directly at this point at x equals 2 has to exist, which that will come up in a later problem in this video. And then lastly, suppose now I want to find f of 3. Well, f of 3, this is undefined. There's nothing there. Now suppose I want to find the limit as x approaches 3. Well, the limit as x approaches 3 is just 4 for f of x. So limit as x approaches 3 for f of x equals 4. So you see, at f of 3, the function's undefined. We have an open circle, but the limit is 4. So now let's look at another problem. I'm going to clear the board, and I'm going to pick a different color. So now suppose I have a function f of x equals x cubed minus 8 over 4 times the quantity x minus 2. And suppose, they show us the graph. This is the partial graph, to say the least. So I have the points 1, 2, 3, and here it's 1, 2, 3. So I have this here, this point, and I have this here. And the graph looks like this, okay? Goes right through here, where this is an open circle, and through there it's a dark circle. So now, suppose I want to find the limit as x approaches 2 from the right of f of x. So anytime they're asking to find a limit, you have this little plus sign up here as an exponent. What that means is it's not an actual exponent. It means you're approaching 2 from the right. So 2 from the right, we're approaching 2 from the right-hand side. Well, from the right is here, so it's a little bigger than 2. So in this case, a little bigger than 2, somewhere in here, I go up, dot, dot, dot. And, so I'm going to pick a different color to demonstrate that. So 2 from the right, it could be somewhere here. And see, it hits there. It's 3, basically, right? So that tells us that the limit as x approaches 2 from the right is 3. And then now, let's look at the left-hand side. Limit as x approaches 2 from the left. Well, 2 from the left-hand side, that's going to be approaching 2 from the left. Well, approaching 2 from the left is here. So let me pick a different color, such as orange. And approaching 2 from the left is here. We go up, and bam, it hits 3. So since the limit as x approaches 2 from the right of f of x is 3, and since the limit as x approaches 2 from the left of f of x approaches 3, well, they're equal, right? So that means that since these two limits are equal of the same value, that means the limit as x approaches 2 does exist. And it exists at, and it exists, excuse me, that means the limit as x approaches 2 exists such that the limit as x approaches 2 of f of x is simply 3. So the whole idea of this chapter is really learning, what a limit is more precisely, and the difference between that and the value of a function at a particular point, and interpreting it from a graph. So the last one I'm going to go over, pick another different color, is suppose I have another graph. The points 1, 2, 3, 4, 5, 6. And then here I have 1, 2, 3, 4, 5, 6. And then I have a point at 2, 1, so 2 of 1. And it goes all the way like that. And then I have an open circle at the point 2, 4. So 2, this is 4. And the graph looks something like that. And again, this is just some arbitrary function, y equals g of x. So now I want to first, let's say we want to see if the limit at 2 exists. Well, first we have to test, the limit from the right side and the left side. Now, it doesn't matter which order you do it in. So suppose I take the limit as x approaches 2 from the left of g of x. Right? So the limit as x approaches 2 from the left, well, approaching 2 from the left is here. Now you see, it's not directly at 2, it's going to be a little before it, which means since it's a little before, it's not going to hit smack at 2. It's going to go up at here at 4, which means that the limit as x approaches 2 from the left-hand side is 4. Now, suppose I have the limit as x approaches 2 from the right-hand side. Well, limit as x approaches 2 from the right-hand side, it's going to be somewhere in here, right? Because from the right, it's going to be a little above 2. Bam, where does it hit? Right there at x at 1. So that means the limit as x approaches 2 from the right-hand side is 1. And you see, now if we look at it, the limit as x approaches 2 from the left of g of x is 4, and the limit as x approaches 2 from the right of g of x is 1. Well, you see, these are not equal. So that means that the limit as x approaches 2 of g of x does not exist. So to recap really quick, a limit is basically, you know, how far you can really, you know, push towards the threshold. So again, if the limit as x approaches 2, well, I can go a little above it or a little below. So it's really how close I get to here. And, you know, basically when we're computing a limit by a graph, if you want to know if a limit exists at a particular point, and this works in general, you'll see later on when you start doing them by looking at a problem and using algebraic techniques to compute the limits, that if you want to see a limit exists at that point, you take the one-sided limit. So again, 2 approaches from the left, yeah, right here, right? It's a little before. Then 2 approaches, limit is x approaches 2 from the right, yeah, it's right here. So the idea is that if the limit is you're approaching a particular x value from the left and the limit is you're approaching a particular x value from the right are the same, that means the limit directly at that point exists. But if they're not the same, meaning the one-sided limits do not equal the same value from the right and the left at that particular limit for that or particular value of x, then that means it doesn't exist, which is this case, because as you can see, these are not the same. And then, you know, if it was, say, find g of 2, a little mark there, say if it was find g of 2, well, g of 2 is right here, it's 1. So what that means is when x equals 2, g is 1. So g of 2 equals 1, which is the same thing as saying 0.21. See, that's finding a particular value of the function, not its limit. I know this concept can be a little confusing, but that's really the whole idea of a limit. And it's really the difference between finding the value of a function at a particular point and finding the limit. So I hope this video helps. I'll see you guys next time. Have a great day. Bye-bye.